Ever heard of Bayesian statistics and probability? Even if you haven't, you most likely practice it daily.
The joke, in a sense, is that all humans are Bayesians because we have this sort of subjective belief about probability that we're assigning to the events around us. And once we observe an event, we then use that event and our subjective beliefs to update what we think is going to happen about the future.
Associate Professor David Frazier works in the Department of Econometrics and Business Statistics at Monash University. He's spent years researching the Bayesian paradigm of probability and says he can explain this key idea with a simple example. Imagine a group of parents who drop off their children for school each day, and every morning the kids are safely escorted across the road thanks to the school crossing guard.
And you watch them cross every single day. Then that is your existing data set. And what a Bayesian does is they say, okay, I have that data set. Now I'm going to update my beliefs about the likelihood of them successfully crossing the road tomorrow via what I've learned and my prior beliefs about that. So my posterior beliefs on the observation of all these data points of them crossing the road is going to lead to a very high probability of them successfully crossing the road. We do this sort of calculation thousands of times a day. We just don't call it Bayesian probability.
Bayesian statistics now plays a significant role in machine learning and artificial intelligence. Billions of data points can be crunched in real time to deliver probable outcomes on things that impact our everyday lives. For instance, services such as Netflix and Spotify use algorithms based on so-called approximate Bayesian methods to suggest shows or songs users may like. Associate Professor Frazier's work has focused on understanding the behaviour of these Bayesian methods and finding ways to ensure they deliver the most accurate predictions possible. He says this is crucial when the predictions can affect much more than the media we consume.
A good example of this is, say, self-driving cars, right? A lot of self-driving cars rely on what are called variational Bayesian methods. Those are methods of approximating an exact Bayesian learner for microsecond updates as to when the car should stop. Robotics uses these methods a lot to try and make sure that when they have self-driving vehicles or drones or something like this, they make sure that they're not going to crash into anything.
Associate Professor Frazier says working at the cutting edge of Bayesian probability has shown him just how important the language of mathematics is to the world we live in.
Every single aspect of our lives now is driven in some fashion by a model. What I do essentially is I use mathematics and statistics and data to test and make sure that those models that we base every single aspect of our life on are in some sense robust.
This work has now seen him awarded the Moran Medal from the Australian Academy of Science in recognition of an outstanding contribution to applied probability and statistics.